26/3. And this would be 26/3 square units if we're talking about rectangles. Okay, the next hint for the extra credit, Thanksgiving extra credit, is found in, look on Blackboard under Assignment, the Assignment tab. So look in Blackboard and then look under the Assignment tab. Okay, well, let's continue on to the next problem. Find a formula for the sum of n terms using this information. The limit as n goes to infinity, summation of I going from 1 to n, 2i divided by n times 2n. Again, keep in mind, I is the thing we're trying to do. Anything else in here is a constant. So we can rewrite this as the limit as n goes to infinity, and this is going to be 2 divided by n, and another 2 divided by n from this, and then we have the summation as I goes from 1 to n of I. Again, Carl Friedrich Gauss, we have the limit as n goes to infinity. This is going to be 4 divided by n squared. This is going to be n times n plus 1 divided by 2. This will give us the limit as n goes to infinity of 4 divided by n squared. Let's back off. Let's make that 2, because our 2 and our 4 can cancel. So that's going to be 2. And then we actually can say our n and our n squared. So 2 divided by n, n plus 1. And again, we're down to very little work we need to do here. But let's see. This is the limit as n goes to infinity. We could break this apart, and we've got 2n divided by n, that's 2, plus 2 divided by n, and our answer would be, as n goes to infinity, the answer would be 2. All of these, as you hopefully are getting the idea, is that when we deal with summation, we try to get down to one of those items that we had in the one of the very first slides here. If it's the summation of a constant, it's the constant times the number of terms. If it's the summation of I, as I goes from 1 to n, it's like Carl Friedrich Gauss example. If we have the summation as of I squared, we have this pattern, n the quantity n plus 1, n being the number of terms, and so forth. By the way, the third clue to the homework is, again, look on Blackboard and go to course information. And good luck on that extra credit. Going back down to our last example then, everything can be reduced using those 4 patterns. And then once we get to that, we just use what we know about the limit as n goes to infinity. The last one, I'm not going to hold you responsible for. We're going to pick this up, and we're going to have, of course, some other ways of looking at our summation of rectangles. What we're doing in this process is to our integrals what the limit definition of a derivative is. And so we are going to be finding out some rules that we can use and having an easier way of doing that. Have a nice Thanksgiving. The extra credit again is in Blackboard under course information. enjoy and have fun doing the extra credit. See you when you get back.